Hey everyone, today we are going to dive into one of the most common and frankly most critical security flaws on the entire web. It's called broken access control. We're going to be looking for the unlocked doors and hidden passages in the apps we use every single day. Let's get right into it.
So to kick things off, just think about this for a second. Could a tiny change in a web address, something almost like a typo, let a complete stranger see or even mess with your private information?
Well, the answer is, yeah, it absolutely can. And this isn't some crazy far-out scenario from a movie. It's a real-world vulnerability, and its name is broken access control. So let's break down what that actually means.
So, what are we really talking about when we say an application has broken access? Let's get right down to the basics. At its heart, it's really all about a failure of enforcement. The application might know who you are, but it completely forgets to check what you're supposed to be allowed to do. This lets people step way outside their intended permissions and get to functions or data that should have been totally off-limits. To really get this, we have to understand a super fundamental idea in security: the difference between proving who you are and what you're actually allowed to do once you're in. Okay, so you have two big ideas here. First is authentication. This is all about identity. It just answers the question, who are you? Think of it like showing your passport at a hotel desk. But then you have authorization. This is about permissions. It asks, okay, now that you're here, what can you actually do? This is like the key card the hotel gives you after they've seen your ID. And this hotel analogy honestly makes it all click. You authenticate with your ID, then you're authorized with a key card. That card gives you access to your room, maybe the gym, but it correctly stops you from getting into the room next door. Broken access control? That's like the hotel accidentally giving you a master key card that opens every single door in the building. So how does this actually break in the real world? Let's look at our first attack scenario, what I like to call the hidden endpoint. This is all about an attacker finding some feature that the server knows how to do, but that isn't shown anywhere on the actual website. So picture a really simple to-do list app. On your screen, you can see a button to add new items, but there are no buttons to edit them, no way to change them. A normal user would just think, okay, I guess you can't edit things. But an attacker starts to wonder, is that feature just hidden? Okay, so let's walk through how this exploit actually works. The attacker adds an item, but they capture the request their browser sends. It's a post request. Then they just tinker with it. They change the method from post, which usually means create, to put, which means update. And you know what? The server replies with an error, but it's a really helpful one. It says ID is required. That is a massive clue. It basically screams, hey, this update feature exists, you just need to tell me what to update. So all the attacker has to do is grab the ID of someone else's item, stick it in the request, and they're in. And this just shows you exactly what happens. The attacker, Alex, found this hidden backdoor and was able to change Jeremy's to-do item from drink water to no water, only coffee. Alex had absolutely no business touching Jeremy's data, but the application completely failed to check. So why did this even work? Well, the root cause is kind of scary simple. The developers remembered to put a security check on the endpoint for creating items, but they just forgot to add that same check to the one for updating them. It was literally a forgotten lock on a hidden door. All right, let's move on to our second attack. This one's a little different. It focuses on processes that have multiple steps, because these are notorious for having security holes. So this time we're looking at a password change feature. You know the drill. Enter your old password, then your new one. Seems simple, right? But any process that has multiple steps, like a shopping cart checkout or a sign-up form, is a prime target for attackers, because getting all those steps perfectly secure is really, really hard. Now, if you're thinking like a security researcher, a few red flags pop up immediately. First, why is the app asking for the user ID? It should already know who I am from my login session. Second, the reset token it gives you just looks a little too simple, maybe even guessable. These little clues tell an attacker that the whole process might be fragile. And this question really gets to the heart of it. A good attacker is always asking why. Why is the app asking for this piece of information when it should already have it? That little question often points to a huge flaw in the app's logic. So here's the exploit. The attacker goes through the password change process just one time, and they get a valid reset token. Now this token is supposed to be a single-use key, but the attacker thinks, what if I just try it again? They send the exact same request with the same token but a different password.
And it works. They tried a third time. It still works.
And that is the devastating discovery. That token isn't a one-time key at all. It's a permanent master key. It never expires, it's never invalidated. Anyone who gets their hands on this token can change that user's password whenever they want, as many times as they want. The entire security of the process is just gone.
Okay, so after seeing these two attacks, you're probably wondering, how can you, or a developer, start to think more like an attacker to find these things before the bad guys do?
You know, it really comes down to developing a hacker mindset. Don't just use an app the way it was designed. Try to break it. Test for those hidden functions. Question everything the app asks you for. Aggressively test every single token you see. And always dig deep into those multi-step functions. Just send it weird stuff. See how it reacts.
And that really brings us to the final thought I want to leave you with. As we've seen, this isn't always about some genius-level code breaking. A lot of the time, it's just about finding a door that somebody, somewhere, simply forgot to lock. It makes you wonder, doesn't it? How many of the apps you use every single day have a forgotten door just waiting to be opened?